morning all, my name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about problem solving on Huffman coding. So what is Huffman coding and why it is related to the image processing we will discuss. Actually, Huffman coding is one of the lossless compression algorithm. Its main motive is to minimize the data's total code length by assigning codes of variable lengths to each of its data chunks based on its frequencies in the data. High frequency chunks gets assigned with shortest code and lower frequency ones with relatively longer code, making a compression factor greater than or equal to 1. But in the information theory, Shannon's source coding theorem expresses that an independent and identically distributed random variable code, average code or length of symbols cannot be similar to that of the Shannon entropy. So actually, image compressions are two types, lossy and lossless. Okay, we are discussing today lossless. So lossless is nothing but a Huffman coding is a one type of lossless coding. So in the Huffman coding is one of the lossless compression algorithm, and its motive is to minimize the data's total code length by assigning codes of variable length to each of its data chunks based on its frequencies in the data. High frequency chunks get assigned with shorter code and lower frequency ones with a relatively longer code, making a compression factor of greater than or equal to 1. But in the information theory, Shannon's source coding theorem expresses that an independent and identically distributed random variable data code rate, average code length for symbols cannot be smaller than the Shannon entropy. But it is proven that Huffman coding algorithm provides optimality following Shannon's source coding theorem. That is, after encoding, it provides the lowest possible bit rate. So when we are going for the Huffman coding for the lossless algorithm, the following are the two steps for Huffman coding. First one is a building Huffman tree and assigning codes to leaf nodes. These are the two types. Building Huffman tree, the first compute probabilities for all data chunks, build nodes for each of the data chunks, and push all nodes into a list. Now pop the least two probabilistic nodes and create a parent node out of them with probability as in sum of both their probabilities. Now add this parent node to the list. But now repeat the process with the current set of nodes until the parent with probability is 1. So majorly Huffman coding algorithm provided optimally a Shannon's source code. So it is nothing but a Shannon source code, but encoding, and it provides the lowest possible bit rate. Okay, lowest bit rate. Huffman coding are majorly two steps in Huffman coding: building a Huffman tree, assigning codes to the leaf nodes. Building Huffman tree, first compute probabilities for all data chunks, build nodes for each of the chunks, and push all nodes into a list. Now pop the least two probabilities nodes and to create a parent node out of them with the probability as the sum of both their probabilities. Now add this parent node to the list. Repeat the process with the current set of nodes until to create a parent with the probability of 1. So probability of 1, it is nothing but a lossless I am taking. So this parent repeat the current set of nodes until the probability equal to 1. If probability equal to 0 means maybe it is a lossy, but when I am going for the probability 1, it is a lossless. To compute the probabilities of all data chunks, build nodes for each of the data chunks, push all nodes into a list. But least two probabilities nodes and create a parent node of them with the probability as the sum of their probabilities of add the parent node to the list, and the process of current set of nodes until to create a parent of the probability equal to 1. So When we are going for the Huffman coding technique, the code will be generated as follows. It is one example of Huffman coding. Huffman coding example. Here I am taking, suppose in character, input character I, T, I am taking one character is a space C, E, and U, I. Okay. And what are the frequencies? Suppose I am taking the character I, the frequency is 6. Here frequency is 5, 4, 3, 3, 3, 2, 2, like this. It is a binary code. For I character, the binary code is 010, 000, 110, 0010, 0110, 100, 100, 0100, It is a 5-bit. I'm taking 5-bit. Here 3-bit, 4-bit, 4-bit, 3-bit, 3-bit, 3-bit. So it is a 5-bit means code length is 5. 5-bit code length is 5. 3, 4, 4. It is 3 and 3. So it is a 3-bit and 3-bit. Total length how much? So frequency is 6 and the total length 6 into 3. 6 into 3 is equal to 8. How I am getting means frequency into code length. So frequency equal to 6 and code length equal to 3, 18. So like this, here frequency equal to 5, code length equal to 3. Total 5 into 3, 15. Frequency 4 and 3, 12. Frequency is 3, 4, 12. So like this, so on, 2 into 5, 10. So it is the 154-bit of Huffman coding compared to 240-bit with no compressions. So when I'm going for the character M, S, A, O, R, D, G, P, like this, I'm taking the frequencies are 2, 2, 2, 1, 1, 1, 1, like this. So it is the coding of how many are there? 1, 2, 3, 4, 5 coding, 5 length, 4, 4, 4, like this. So total length 5 into this one 2, 4 into 2, 8, 4 into 2, 4 into 2, 6 into 1, 6 into 1, 5 into 1, and this 5 into 1. So what is the total length? So here what is the formula? Total length equal to frequency into code length. So it is a Huffman coding or compared to 240-bit with no compressions. So it is one example. So in this Huffman coding, what we discussed here, frequency, code word, code length, binary code, and character. So these are the important. If I am taking the character, it is the one, and the frequency is there. Character means A, B, C, D, and what is the frequency? I am taking the numbers of 6, 4, 3, like this, and what is the code word? 110, 110, like this. So I am taking 3-bit or 4-bit or 5-bit, like this. And what is the code length? I am taking the code length is there. So total length. So it is one example of Huffman coding technique which is related to the frequency and the code length and the total length. So it is another example of Huffman source reductions. So original source, it is a original source and a source reduction. So it is a original source. Up to this one, it is a original source. Here up to this is a source reduction. Okay. So symbols A2, A6, A1, A4, A3, A5. That means A1, A2, A3, A4, A5, A6. So what is the probability of each one? So this one, suppose A1 equal to 0.1, A2 0.4, A3 0.06, A4 0.1, A5 0.04, A6 0.3. Okay, so these are the different lengths we are taking here, and this I am taking as a original source, and source reduction we have to go for this one. So when we are going for the source reduction, original source to source reduction, so what is the process means? I am taking bottom 2, 0.06 plus 0.04. So how much is there? So 0.06 plus 0.04 is equal to 0.1. So it is 0.1. So 0.1 asterisk, 0.1 asterisk, 0.3 and 0.4. It is a level 1. So next level 2. Level 2. So bottom 2, 0.1 plus 0.1. So 0.1 plus 0.1. It is a 0.2, 0.3 and 0.4. So next level 3. 0.2 plus 0.1. 0.2 plus 0.1. How much? 0.3. So it is a 0.3. It is as it is. So next 0.4 least one and this one. So 0.3 plus 0.3 is equal to 0.6. So 0.6 plus 0.4 is equal to 1. What is the probability? 1. So source reduction equal to 1. It is a level 3. It is a level 4. So in the total in the within the level 4s, in level 4s, probability equal to 1. Probability equal to 1. So what we done? Original source and source reduction. So it is example 1. So original source to source reduction. So what is the symbols? A1, A2, A3, A4, A5, A6 and I gave the probability values. In the level 1, bottom 2 is added. Level 2, last bottom 2 values. Level 3, bottom 2 values. Level 4, bottom 2 values. So total how much I got means only probability of 1. So assigning the codes to the leaf. In the next step, what you have to do? By following the tree built from the above procedure at any arbitrary node to assign its child nodes with child underscore word, current encoded word plus of 0 by 1 to each left right nodes, applying this procedure from the root node. So same in the previous example, original source and source reduction. So I am taking the A1, A2, A3, A4, A5, A6 and the probability values are there. And what is the code word? Here they give the, in the previously source symbol and probability is there. But here I am taking source symbol, probability and code also there. So what is the code here? Here 0.4 code is 1. Here A6 code is 2. Here 0.1 3 code. Here 0100. Here 01010. Here 01011. Okay, they gave the codes also. So what is the next step? Up to here original source is there. Up to now I have to go for the source reduction. Okay, it is a question and it is a answer. So I am taking 0.4 3 1 1. Last these values I am added. This I am adding to this one. 0.06 plus 0.04 equal to 0.1. So this 0.1 is there. So 0.1 asterisk 0.1, 0.3 and 0.4. Next, what are the codes means? 1, 0, 0, 0, 1, 0, 0, 1, 0. So 0, 1, 0, 0, 1, 0, 1, 0 plus 0, 1, 0, 1. So what is the final value I am taking here? I am taking as a 0, 1, 0, 1 value. So next, what is the top, bottom values? So this I am taking the bottom values. So here the 0.1 I am writing here. 0.1 plus 0.1, it is a 0.2, 0.3 and 0.4. This 0.1 plus 0.1 equal to 0.2. It is like this. So this value is 1, 0, 0 and it is a 0, 1, 0 and it is a 0, 1, 0, 0, 1, 1. Next, bottom two values. Okay. So 0.3 I am taking like this. These two values. What is that means? 0.2 plus 0.1 equal to 0.3. So 0.3, this 0.4, this 0.3 and addition of these two values 0.3. So this one is a 1, 0, 0, 0, 1. So I am taking as a 0.4 here. This 0.3 plus 0.3 here. So 0.3 plus 0.3 is equal to 0.6. So 0.6. So this 0.4 binary value is 1 and after this addition it is 0. So it is a level 1, level 2, level 3 and level 4. So it is a original source with source reduction. In the previously just here character, frequency, code, code length and code word is there. But here symbol, probability is there and converted to the source reduction. But here symbol, probability, code is there and converted to the within the 4 levels the probability is 1. So continuation of this one. Huffman coding is a lossless data compression technique, and Huffman coding is based on the frequency of occurrence of a data item, that is a pixel in images. The technique is to use a lower number of bits to encode the data into the binary codes that occurs more frequently, and it is using in the JPEG. So when it is a lossless So Huffman coding is a lossless data compression technique, and it is based on the frequency of occurrence of a data item in the pixel images. And the technique is to use a lower number of bits to encode the data into the binary codes that occur more frequently, and it is used in the JPEG format. It is one example of Huffman coding. I'm taking the input values are message x1, x2, x3, x4, x5 and x6. And stage 1, the values are 0.3, 0.25, 0.2, 0.12, 0.18. So these are the input values. So bottom 2 values, that means 0.08 plus 0.05. So how much? 0.13. So this value is 0.13. So this I am taking here 0.12. So 0.2, 0.25, 0.3 as it is I am taking here. So this 0 and 1, here I am combining this one here is a 0, and this probability of 1 equal to I am taking is a 1, 0 and 1. So these are all as it is. So 0.13, 0 when I am taking it is a 0 and it is a 1. So it is a 0 and it is a 1. So in the first level, what is the stage 1? Stage 1, 0, 1. What about the stage 2? So 0, 1. Stage 2, 0.13 and 0.12. So 0.3, these are the as values are there. 0.13, so 0.25 and 0.2 like this, here like this. Okay, here 0 and 1. So again here 0.25 here, 0.25 plus 0.2, 0.25 plus 0.2, 0.45. So this I am taking 0.45. Why? Because it is the highest value, lowest, middle value, lowest value. So increasing to decreasing order. So 0.45, 3, 2, increasing to decreasing. So bottom 2, 0.3 plus 0.25 is a 0.55. So increasing to decreasing, higher order value, lower order value, 0.45. If I am adding both of this one, 0.55 plus 0.45, what is happening? Total equal to 1. So the probability equal to 1. So example 1, construct code word using arithmetic coding for the sequence S0, S1, S2, S3 with the probabilities of 0.1, 0.3, 0.4, 0.2. So I am taking as a S0, S1, S2, S3, 0.1, 0.3, 0.4, 0.2. So S0 equal to 0.1, S1 0.3, S2 0.4. It is like this. So already they gave the symbol intervals. They give like this. Okay, it is a question. So we have to convert to the answer. So here I am taking as a values of here input sequence S1. I am taking S0, S1, S2 and S3. S0, S1, S2 and S3. So what are the probabilities means 0.1, 0.4, 0.8 and 1. So what we have to do here? Here I am taking the orders from higher order to lower order or lower order to higher order values. Here I am taking 0.5. Suppose here I am taking 0.1. Here I am taking. So what are the remaining values are there? Here I am adding these two here at the S0. Got it? what is the value of S0 here? 0.1. Here S1, here also S2 value 0.4. So S3 equal to 0. Like this. Okay, it is a code interval. So 0.13, 8 plus 4 and 0.2, 0.35. Next I am taking as a 0.1, 0.53, 0.124 like this. Okay, it is a input sequence and code interval. So continuation we will discuss now. So in the iterations I am taking first iteration S0, S3, S2, S3, S3 like this. Okay, so these are the frequency ranges or code intervals. So I am taking another problem of a DMS X has a 5 equally likely symbols P of x1 equal to P of x2 equal to P of x3 equal to P of x4 equal to P of x5 equal to 0.2. Construct the Huffman code and calculate the efficiency. So here already they give P of x1, P of x2, P of x3 and P of x4, P of x5. So is equal to 0.2. x1, x2, x3, x4, x5. P of xi equal to 0.2 m into m1, 0.2 into m2, 0.2 into m3, 0.4 m5. It is like this. Okay, last two values. What we have to do? I am taking this is a 0 and this is a 1. Okay, 0.2 plus 0.2, 0.4. Okay, I am going for the higher order to lower order. So it is a higher value. I am taking as a 0.4. What is means x4, x5 means m4 and m5. So remaining all as is I am taking. So m1, m2, m3. So what is the next step? Level 2. So what is the level 2 means? It is level 1 is completed. In the level 2, bottom 2 values 0.2 plus 0.2. It is a 0.4 with m2 plus m3 and 0.2 plus 0.4 is as it is. Okay. In the level 3, what we have to do? 0.4 plus 0.4. Okay, it equal to 0.8. So m2 plus m3 plus m4 plus m5. But here m1 plus m4 plus m5 I have to adding. So what is happening means 0.6. Here it is a m2 plus m3 is 0.4. So when I'm adding both are this one means I'm getting the one probability is 1. So x1, x2, x3, x4, x5 0, 0, 1, 0, 1, 1 this one. Code length is like this. It is a 3 bit, 3 bit, 2 bit, 2 bit, 2 bit. So like this. So when I'm adding these two, I'm getting the probability equal to 1. Probability equal to 1. So h of x equal to minus summation of 5 comma I equal to 1 p of xi log of 2 p of xi equal to minus 0.2 log 2 of 0.25 into 5. H of x equal to 2.32 and length equal to p of xi into n. So what is the final one means 96.7 is the final value I'm getting. But what are the properties of Huffman coding? Optimum code for a given dataset requires 2 passes. Code construct complexity n log n. Fast loop table based implementation requires at least 1 bit per symbol, and average code word length is within 1 bit of 0 order entropy. That is a tighter bound are known as a H plus 1 bit and susceptible to bit errors. So in the properties of Huffman coding, optimum code for a given dataset require code construct complexity, fast lookup table based on implementation, and requires at least 1 bit per symbol, average code word length in within 1 bit of 0 entropy, tight bounds of known, and susceptible of the prints. So in these properties, everything is important for this one. So in the properties, first one, construct complexity equal to 0, that is a n log n. So when I'm going for the lookup table based on the implementation. So what is a lookup means? Everything is a code word, code length, and frequency is important, and requires at least 1 bit per symbol, 0, 0, 0, 1 like this, 1, 0, 0, at least 1, and average code word length is within the 0 order entropy, that is HRH plus 1 bit, and sustainable to bit errors. So these are the properties of Huffman coding. I'm taking example 3. Perform the source reduction from the following original source. It is a original source A2, A6, A1, A4, A3, A5. So these are the values like this. So when I'm going this one, so first bottom 2 values, that is a A3 plus A5, 0.06 plus 0.06 plus 0.04. So what is the value? 0.1. It is the 0.1. So remaining all I'm taking as it is. It is a level 1. And in the when I'm going for the level 2, this I'm taking 0.1 plus 0.1. It is a 0.2. And it is 0.134, increasing to decreasing order. So after then I'm adding both of this one, 0.3, 0.3. So it is increasing to decreasing order. 0.3 plus 0.3, 0.6, increasing to decreasing order. Okay, it is a level 4. So level 3 and level 4. So in the original source it came and the source reduction also came. So in the 0.6 last is 0.1. So I'm taking the code word equal to 1, 0, 0. In the previously I didn't get any code word. So no code word here. But here I have to take the code word. So 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1 like this. Okay. So when I'm going this, adding this code word, here also 0.010, what is a code word? So when I adding these two, what is a code word? 010. When adding these two, what is a code word? When adding to this two, what is a code word? So this message x1, x2, x3, x4, x5, x6, x6 I'm taking. So here different stages are there. So every stage what is happening here. So 8 plus 5 I'm taking as a 13. Here 12 as it is 0.2, 0.25. Increasing to decreasing order. Here also increasing to decreasing order. So 0.3 plus 0.25 and 2 is I'm taking this like this. So 3, 2.5, 2.5, 2. So increasing to decreasing order in the stage 4. 2.5 plus 2, 0.45, 0.3, 0.25. And this last two values I'm taking 0.55 and 0.45 like this. So when I'm going for the problem solving as Huffman coding, so when I'm going for the image segmentation, the region-based segmentation, it consists of partition of image into the regions that are similar according to a certain set of criteria. The region-based segmentation techniques involves an algorithm making segments by dividing of image into various components that have similar pixel characteristics. But this technique searches for small or big chunks in input image for segmentation purposes. It will either add more pixels to the selected chunks or further the chunks are smaller segments of merge them with a smaller chunk points. So if I'm taking this is the input image, it is the output image. So this input image is a grayscale and converting into the color plus segments, color with segmentation. So in this segmentation there are edge based technique and region based technique and threshold technique. So in that in the segmentation method, first one is a based on discontinuity and based on similarity. So based on discontinuity, edge based, and based on similarity, thresholding based, region based, and spatial theory. So based on this one, neural network, clustering based, and wavelet based. So region based segmentation is a region can be classified into a group of connected pixels exhibit similar properties, and this similar between pixels can be terms of intensity, color, and this type of segmentation, some predefined rules are present which have to be obeyed pixels in order to be the classified into similar pixels. And the region based techniques are further classified into two types of based on this approach, region growing method and a region splitting method. So in the problem solving of Huffman coding is a one type of lossless compression algorithm, and its main motive is to minimize the data of total code length by assigning the codes of variable length of each of its data chunks based on its frequency in the data. High frequency chunks get assigned with the shorter code of the lower lengths of the relative longer code, making of the compression. And the information theory of Santhosh coding theorem expresses that independent and identical distribution random variable, and the symbols are average length code and symbols, and it cannot be smaller than the Shannon's entropy. And Huffman coding is the following two types: building Huffman tree and assigning code to leaf nodes. So each is a Huffman code with a character, frequency, code length, and the total length, and original image source and the source reduction. It is a symbol and a probability and a level 1, level 2, level 3, and level 4. So it is assigning codes to the leaf nodes. So Huffman coding is a lossless data compression technique, and Huffman coding is based on the frequency of occurrence of a data atom, that is pixeling images. This technique is to use a lower number of bits to encode the data into the binary codes that occurs to the more frequently is to the JPEG. And here I'm taking one message x1, x2, x3, x4, x5, x6 with stage 5 stages are there. So here one example to construct a code word using the arithmetic coding of S1 to S3 0.1, 3, 4, 4, 2. So we have to form a code that is L and H code length. So it is a probability of DMS X has a 5 equally likely symbols. P of x1 equal to x2 equal to x3 equal to x4 equal to x5 is the total value equal to all are equal to 0.2. So here x1 equal to 2, length all are 2. Here last one is a 3. So 0.2 m1, 0.2 m2, 0.2 m3, 0.2 m4, 0.2 m5. So in the level 1, level 2, level 3, I'm added the value is a final one equal to 0.1 and the probability equal to 1. And what are the properties of Huffman coding is that code constructor complexity, fast lookup table based on implementation, requires at least 1 bit per symbol, and average code word length is within 1 bit of 0 order entropy, and the tight bounds of H or H plus 1 bit susceptible to the bit errors. And what is the performance source reduction of the following version is suppose I am taking symbols and the probability. So 2 inputs I am taking. So what are the outputs here I am taking? So symbol, probability, level 1, level 2, level 3, level 4. So what is the final one equal to 1? So probability equal to 1. So here also original source and source reduction, final value equal to 0.6 plus 0.4 equal to 0.1 and code word equal to 0.1. So here also one message with 5 stages are there. So it is about the Huffman coding. So total equal to 0.1. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.